So we're just going to graph the pieces of this thing. Let me see if I can make it any bigger. Okay, look at problem number 1. I want you to see it as two different lines that need to be graphed. Okay. So you see this one that says x plus 2? I want you to see that as y equals x plus 2. That's one piece of this graph that we're going to graph. So let's go ahead and graph this one. Okay, let's go ahead and graph the line y equals x plus 2. But make sure you're doing this in pencil because we're going to wind up erasing parts of it. So just do this very gently and sort of dot it. All right, bring me your phone. You heard me. Okay, so y equals x plus 2. If I were going to graph this, where would I put my first dot? At 2, at plus 2. So just put a dot at 2, sort of lightly. Oh, go get one from my desk. So we put our first dot at 2. Where will I go from here? Up 1 over 1. You guys are scaring me now. Okay? Normally we look at the slope to know how much we go up and to the right. When there's no number there, that's a 1. Okay? So that x means 1 over 1 is the slope. So I was starting from my y-intercept of 2, and then I'm going to go up 1, right 1. Okay? Just do this very lightly because we're going to wind up erasing a lot of this in a minute. But go in both directions, please, just like we did on Thursday. Okay? So that shows you where the line y equals x plus 2 is. But this graph is in two pieces. We're not going to get to draw this entire line. We're only going to draw part of the line. Now, the way we know which part of the line to draw comes from this part over here, where it says the x values are less than 2. This is what tells us which part of this line to draw. We're going to draw the part of this line where the x values are less than 2. Now, let's start with the one where the x value is exactly 2. Look at all these dots we just drew. If I want to find the one where the x value is 2, is this one it right here? What about, is this one it? What's the x value of the point I'm pointing at? That's 1. What about this one? Okay, can you guys see that this one is the one where the x value is 2? Okay? Right, because we're looking left and right. So here's the one where the x value is 2. Okay, so here's like the x value of 2 right here, sort of pointing up at it. Now, we want the part of the line where the x values are less than 2. So am I going to highlight the part of the graph that goes to the right, or am I going to highlight the part of the graph that goes to the left? To the left. Okay, less than 2. X values less than 2 means I'm going to look to the left. So that's why I'm going to draw in the left side of the line. So I'm going to go ahead and draw that in. That's the first piece of the graph. Now, some details. First of all, let's erase those dots that we drew that were not needed. Now, notice how I left this as a big old open circle. That was on purpose. Can anybody guess why sometimes it will be an open circle, sometimes closed? Mr. Perez, any guesses? It's not included. X is less than 2, not equal to. When it's just less than, that's when we're going to have an open circle. If it were equal to, like the next one is, it'll be a closed circle, included. Okay? So we're halfway finished. Now let's do the bottom part. Okay, so looking at the bottom piece of this piecewise function, I want you to view this as y equals -1/2 x plus 6. All right. Where will I put my, maybe I should do this in a different color. Where will my first dot go now?
6.
At 6. Okay, that's 2, 3, 4, 5, 6. There's my first dot at 6. Okay, where shall I go from here? Down 1, right 2. Because it's negative, I'm going down. So down 1, right 2. 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 Okay? So these blue dots show me where the second piece of my function is. Now again, I'm only going to draw part of this line. I'm going to draw the part where the x values are greater than or equal to 2. Well, notice in this case that's the same number that I was dealing with before, an x value of 2. So it should be easy to see that this dot that I just made really dark, that's the point on this line that has an x value of 2. So I'm going to start with there. Why did I darken it in instead of leaving it open this time? It's included. Greater than or equal to 2. So I filled it in. Now, am I going to draw the left side or the right side this time? The right-hand side. This says greater than or equal to. Greater than will be to the right. So I will draw this side of the line. And I will erase the dots that I didn't use. And that's it. That's how you graph a piecewise function. Now, let me mention something else that will help avoid half of the mistakes that students make. Are you listening? Are you ready to avoid half of the mistakes that you make? Function. How do you look at a graph and tell if it's a function or not? From the graph. But look at, how do you know from the graph though? He passes the test and he's going like this. Can anybody put some words to it? Passing the vertical line test. Okay? Piecewise functions are still supposed to be functions. They should pass the vertical line test. So if half of the mistakes you guys make are you will shade in the wrong sides of a line. So say if I accidentally shaded in to the left, it wouldn't pass the vertical line. Let me just show you real quick. Say if I made a mistake and I thought, oh, my graph will be graphed to the left. Okay, say if I did this and I thought I would be graphing this side of the line. Okay, I thought the red was the way to go. Why will I immediately know I made a mistake? Because that wouldn't even be a function. Looking at the red stuff over here, this would fail the vertical line test right here. So please make sure any graph you draw, it better pass the vertical line test. Okay, so there, I just saved you half the mistakes you guys make. Alright, anyway, that's how you do it. Bah. Okay, domain and range. We still have to be able to know the domain and range. I bet most of you will guess correctly the domain for this one. Why am I only hearing a noop? Come on, people. What's the domain? Yeah, it's still going to be negative infinity to positive infinity. It goes left forever, it goes right forever. Is the range going to be negative infinity to positive infinity? No, talk to me. Go, India. Correct. She said, look, remember bottom to top. So negative infinity because, look, it goes downward forever. But at the top, it has a ceiling up here. All right? The highest it gets is 6. So negative infinity to 6 included. All right, let's move on to number 2. Okay, so looking at number 2. When you see this number 2 right here, I want you to see it as y equals 2. Now, we reviewed this on Thursday, so I'm hoping it's back in the front of your brain. Who can tell me how to graph a line like that, a tiny little equation, y equals 2? All right, I see people going like this, horizontal. Y equals a number is just a horizontal line. So you know this is just going to be a horizontal line at 2. So it's going to be doing this type of a deal. Okay? But am I going to draw this entire line from left to right?
No.
No. I'm only going to draw the part of the line where the x values are less than -1. Am I thinking left or right when I look at this? When I look at this, I'm thinking left because less than is to the left for x values. Okay, so I look for the -1, which is the cutoff point. Can I see that this is the place where the x value is exactly -1? Okay, that circle that I just made. That's the value that's -1, x value of -1. And like you just told me, I'm going to graph to the left. So I will start from here and I will graph to the left. So I'm halfway done. Easy, right? Do I fill in this circle that I just made? No, because it's not or equal to. It's just less than. So I'm halfway done. Let me change colors and let's do the other part. Feel free to get ahead of me if you have the ability. For the other half, I want you to look at this as y equals 3x minus 2. Where do I put my first dot?
2.
Not 2, but -2. Then where do I go from here, guys? Up 3, right 1. Up 3, right 1. Put one on the left as well. So these 4 dots show me where my second line is going to be. But again, I don't get to graph the entire line. I'm only going to draw the part where the x values are greater than or equal to -1. So this part is the part that goes to the right because it says greater than or equal to. So I start by finding the point that's at -1. Can you guys see that this dot down here? Because I'm thinking of x values. This is the dot that has an x value of -1. Does that make sense? All right, Street, do you understand why I'm picking this one? Yes. And of course, I'm going to graph to the right this time. So this is the side that I will graph. And that's it. That's how you graph a piecewise function. Just graph the pieces, and you're done. Is the domain going to be -infinity to positive infinity again?
Yeah.
Yes. It won't always be. So you have to really look at each one this time. But for now, it's still a -infinity to positive infinity. Margaret, can you tell me the range for number 2? Yes, but I don't think it was -6. Isn't it -5? It's looking like -5 to me. But yes, -5 to positive infinity. Okay? Any questions about number 2? All right. Let's look ahead to number 3. Oh yeah, evaluate. Hold on. Okay, evaluating. This is like another skill. You need to be able to evaluate a piecewise function. Now, do you guys remember what this meant when we had a regular function? Like if I just had, if I had the function f of x equals x squared minus 5, and I wanted to evaluate this, f at -3. Do you remember what that meant to do? It meant to plug it in, right? It meant take that -3, put it in there, and see what you got. So like that would be -3 squared minus 5. So that would be 9 minus 5. So the answer would be 4. Okay? So that's what it meant to evaluate when it was just a regular function. But when you have a piecewise function, it's a little bit more complicated because we have two different functions. We have the x plus 2 function, and we have the -1/2 x plus 6 function. Hear me closely on this. Do not use both functions. You will only use one when you're evaluating. Do not give me two answers. That's a common mistake that kids will make. One answer only. So it's a matter of knowing which one of these I'm going to use. And I'm going to, these statements on the right-hand side. If the x value is less than 2, I'm going to use the top one. If the x value is greater than or equal to 2, then I'm going to use the bottom one. That's what I'm going to go by, these little statements on the right. So let's look at the first one. -3. Is -3 less than 2?
Yeah.
Or is it greater than or equal to 2? -3 is less than 2. Okay? Because, think of it like a number line, right? Think of it this way. Okay? Like there's 0, right? So 1, 2, there's 2. There's -3. It's to the left, so it's less. Think of it that way. Okay? So, -3 is less than 2. That tells us to use the top function. So, y equals x plus 2. So, for this one, we use y equals x plus 2. This becomes y equals -3 plus 2. This becomes y equals -1. Okay? That's how you do it. Now, 2. If I'm going to evaluate at 2, let's look back. Am I going to use the top function or the bottom function? I'm going to use the bottom function because of the equal to 2 part. The bottom function has the equal to 2 part. So the bottom function is -1/2 x plus 6. So I'm going to use y equals -1/2 x plus 6. This becomes y equals -1/2 times 2 plus 6. Now, if you needed to, you could put this in your calculator. Okay, but I know that these 2's are going to cancel out. That makes -1 plus 6. That makes 5. But if you needed to type it into your calculator, you may. But you should get 5. Let's look at the last one. 6. Am I going to use the top function or the bottom function for 6?
Bottom.
Definitely the bottom function. 6 is greater than 2. So I will use the bottom function again. Okay, so I will use, once again, y equals -1/2 x plus 6. That makes y equals -1/2 times 6 plus 6. If you need to just put that in your calculator, you go right ahead. Okay? But what I will do is, what's half of 6, you guys? Half of 6? 3. So that makes this -3, because half of 6 is 3. So -3, then plus 6, so that makes this +3. That's how you evaluate. Okay? Now, let me let you in on a little secret. Everybody watch this. I know I'm teaching you a lot of information, but it's helpful to you. I could have gotten these same answers from the graph. Let me show you how you could get these answers from the graph. It'll probably take you a couple times to understand this, okay? But watch this. If I want to evaluate the function at -3, for example, okay? Remember, this is an x value of -3. this is what I could do. I could put basically a vertical line at -3. Okay? Sort of like the vertical line test, right? So if I put a vertical line at -3 to kind of show me here's an x value of -3 over here. Let's see, what color? I'll make this purple. Okay, look at that purple line I just drew at -3. Wherever that vertical line touches my graph, that's the answer. Okay? Now, can you see where this vertical line touches my graph? It touches at -1. I guess I didn't draw it real precisely. But yeah, it touches right here at -1. Okay? That's why the answer is y equals -1. Okay? Let's do that again. And you can just do it visually, you know? Just look, vertical line, boom, answer. Okay? Look at the 2. I'm going to move my vertical line. I'm going to move my vertical line over to 2. Oh, that's too slow. All right, if I take my vertical line and move it over to 2, just look for where does that vertical line now hit the function. If you're not careful, it looks like it's hitting in 2 places, doesn't it? Is it really hitting in 2 places, or is it hitting only 1 place? It's really only hitting 1 place because one of those dots is empty. Where is it hitting right now? It's hitting right here at +5. Okay? That's why the answer is 5. That's another way to look at it. Andrea.
Why is it just 6 if the top's at 5?
It's not. I miscounted. No. Yeah, I miscounted.
So 5.
Yeah, it's 5. Yeah, I don't know where I got that from. Yes. Okay. So look at number 2. Let's evaluate number 2. Let's not forget the evaluate part. So looking at number 2, if I want to evaluate this algebraically using the equations, if x is -2, let's see. Well, that is less than -1. That tells me to use the top equation. Look, you might be asking yourself, hey, wait a minute. The top equation just says y equals 2. Where am I going to plug in this value? Where do I substitute my -2 into? There's no x. Well, guess what? When you just have an equation like this with no x to substitute into, the equation itself is just giving you the answer. It's telling you the answer is going to be 2 no matter what. That's how you handle that. So boom, no matter what, it's 2. Okay? Let's see. 0. Is 0 less than -1, or is 0 greater than or equal to -1? ¿Qué opinas? Think of the line, okay? Think of it as a number line. There's 0, okay? Here's -1. Anything to the left is less, okay? So that's why if I say 0, if I talk about 0, es mayor que -1 porque queda a la derecha. Okay? Alright, 0 is bigger than negative 1. So that's why for this one I would use the bottom equation, because 0 is bigger. So 3x minus 2 is what I'm going to use. So this becomes 3 times 0 minus 2. So that's just negative 2. Okay? And then negative 1 itself. Well, negative 1 equals negative 1. So that tells me to use the bottom equation. This becomes y equals 3 times negative 1 minus 2. That's negative 3 minus 2. That's negative 5. Okay? So that's what I should get by evaluating. Just one more time, let me check any one of those. Say if I wanted to check this negative 1 answer. If I want to evaluate at negative 1, then again, I could just take my vertical line. Do I have it? Did I lose it? I didn't get it. I could just do a vertical line at negative 1, and that would show me what's going on. Okay, so you see that vertical line at negative 1. Let me make it bigger. So you can see, oh, that vertical line is hitting right here at negative 1, 2, 3, 4, 5. So that's why that answer is negative 5. You can get it from the graph. Okay. Are you ahead of me? Have you finished number 3? Okay, here we go. Y equals 2x plus 3. Start off with the y value at 3. You go up 2 over 1. Up 2 over 1, up 2 over 1. Do it in both directions like I taught you on Thursday. Okay, so this is what I have graphed so far with my dots. Oh, Braylon, come on, buddy. Now, am I going to graph this whole graph? No. I'm going to graph this part, the part where the x values are greater than or equal to 0. Which one of these dots is at an x value of 0? Is it this one, this one, this one? It's this one. Okay? This one that I'm darkening in. That's the one that's at an x value of 0. Okay? Now, am I going to graph the part of the line that's on the left or the right? I'm going to graph the right side. Because it says greater than or equal to. So that means I'm going to graph this part of it. Okay? So that's the graph for that one. I can erase the dots now. Okay? Now the other one. So this is y equals x plus 4. So I'm going to start off at 4. And I will go up 1, right 1 from there. So up 1, right 1, be like here, here, here. I must go backwards as well. So here, here, here. Now, I need to graph the part of the line where the x values are less than 0. So that means this time I have to graph to the left. I knew I had to graph to the left anyway. If I graph to the right, it wouldn't be a function. It would fail the vertical line test. So I definitely have to graph to the left. Now, be careful. This has to be an open circle. So make sure this first one that's at 0 is an open circle. Then I will graph it from there. Okay, so that is what your graph should look like. Any questions about where that graph came from? What's the domain of this? What's the range? Yes, the range is also negative infinity to infinity. Because this time it goes up forever and down forever. Why is the blue one going down? If I evaluate the function at 0, let's practice doing it from the graph for a second. If I do it at 0, I glance, bam, 3. Can you see how that is? I just looked vertically at 0, I looked up, the graph's at 3. Boom. If I look at 2, okay, watch this. I go over to an x value of 2, and then I look and see where's the graph. Boom, it's right here. Here's where the graph is when I'm at 2. What is that? 2, 3, 4, 5, 6, 7. So I can immediately, if I trust my graph, I can immediately see that the answer is 7. What about at negative 2? Well, here I am at negative 2. I think I'll use a highlighter mark this time. Here I am at negative 2. I make a vertical line and see where I am. I'm right here at positive 2. So that's really the quickest way to do it if you trust your graph. But I could have plugged those values into the equations as well if I wanted to. Any questions so far? All right, look at number 4. Okay, number 4 is a bunch of these little equations. Okay, I've got y equals 5. What does that look like when I graph y equals 5? That's just a straight horizontal line, okay? It's going to be y equals 5 when the x values are greater than 7, okay? So look, I've got this horizontal line at 5. 1, 2, 3, 4, 5. Okay, there's my horizontal line at 5. But I'm going to draw the part where the x values are greater than 7. So this is 1, 2, 3, 4, 5, 6, 7. Here is 7. Here are the values that are greater than 7. Okay, so that's the first part. Now, let's look at the next part. How many of these do I have? Okay. I've got y equals 3. Y equals 3 is a horizontal line at 3, so that's like this. But it's going to be this line. That's interesting. If I were going to read this from left to right, this says 5 is less than x, which is less than or equal to 7. But I think I've taught you guys to look at this. There's one word that should be popping into your mind when you see this. Does anybody know what that word, what is suggested by this statement? It is a segment. Okay? When I look at something like this, I think the word between. Between. We are between 5 and 7. Okay? So it's going to be between 5 and 7 on this line. So 1, 2, 3, 4, 5. Open circle. 6, 7. Closed circle. I'm going to be between 5 and 7. Does everybody see why I made the 5 an open circle and why I made the 7 a closed circle? Is that part clear? Did I lose anybody? Okay, let's do the next one. Okay, y equals 1. So that's a horizontal line at 1, like this. Now it's going to be 1 between 3 and 5. Okay, so here's 3, and here's 5. Between 3 and 5, like that. Open circle, close circle. Did I lose anybody? All right, last one. Y equals -2. That's a horizontal line at -2. That's going to be like this. Okay? But it's going to be where the x values are less than or equal to 3. So here's where the x values are equal to 3. Less than 3 will be to the left. Okay, so that is how you would graph number 4. Any questions about how I did number 4? Okay. What's the domain of this function, you guys? It's still negative infinity to positive infinity. It goes left forever, it goes right forever, there are no breaks in between. Now the range is different and new. So everybody pay attention. You've never seen a range quite like this before. Okay? Now, if I were just to ask you and let you volunteer your guesses, some of you right now are thinking -2 to whatever this is. -2 to 5. If you're thinking -2 to 5, you're close. But here's the problem. Look at these gaps. Can you see the open spaces between -2 and 1? There's a gap. Between 1 and 3, there's a gap. It's not continuous. It's not continuous vertically. So I can't just say -2 to 5, because that would mean all y values were included. Instead, it's finite. I'm just going to make a list. A list, I have exact y values only. Can you list for me the y values that are included in the range? -2, 1, 3, and 5. That's it. It's just those 4 values. There are no other y values included in the range. It's not between those, it's just those. So that's how you do it when it's like that. Okay? Sir, graph. Okay, evaluating. If I want to know at 6, I will look to an x value of 6. 2, 3, 4, 5, 6. Boom, it's the green one at 6. What's the value of this green one?
6.
No. Give me what's the y value of the green one? 3, right? Okay, the answers are y values, okay? So at an x value of 6, the y value is 3, okay? What about at an x value of 3? I should change color. Okay. At an x value of 3, the y value is -2. So that one's going to be -2. At an x value of 9, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. At an x value of 9, the y value is 5. So that one's going to be 5. Okay? All right, glance over at the back. There's no sting. Graph the given the graph of a piecewise function, write the equation. So for these, we're going backwards. Okay? So let's see. I like to go from left to right. So I'm going to do the left piece first. Now, you guys watch this really carefully. If I want to write the equation for this piece right here, I need to see where it would touch the y-axis if I kept going. So can you see the slope of this thing? I see it's hitting that point, for example. So it seems to be going down 1, right 2. Down 1, right 2. Bam! That would be my y-intercept. And it would keep going like that. Down 1, right 2, down 1, right 2. Now pay attention to that y-intercept. I'm going to need that in a second. So when I go to write the equation, because it's down 1, right 2, what is the first thing I'm going to write in my equation? Negative 1 over 2. X. Okay, the slope of that first line is negative 1/2. So I go negative 1/2 x. Now it's time for the y-intercept, yes? What was my y-intercept? Negative 3. So I will say negative 1/2 x minus 3. Okay? Now, let's look back at some of these other equations to remind ourselves. We need the little part on the end. If x is, greater than or equal to something, okay, or less than or equal to something. I need that part now. I need the if part. If x is. Now, so, looking at this graph, see this open circle right here? What's the x value of this number? Yeah, the cutoff happened right here. Okay? The cutoff is happening at negative 2. That's why this number is going to be negative 2. Now, this first line, is it less than negative 2 or greater than negative 2? Is it to the left or to the right? It's to the left. So is that less or greater? That's less than, okay? So it was this one when the x values were less than negative 2. So now I'm done with that part. Okay? Now the other part. Let's see, what's the slope of this one? 1. It's like up 1 over 1. So that's just x. Okay, what's the y-intercept of the one I just drew in red? 3. There's my y-intercept right there. So that's x plus 3. If x is greater than or equal to negative 2. They share the same cutoff value. That's how you do that. All right, we'll practice that more tomorrow. We'll have to leave it there.